Hello guys, I am here with another topic related to scalars and vectors, and in this lecture we will also learn how to represent a vector graphically. So without wasting any time, let's go to the basic definitions of scalars and vectors. What is the difference between scalars and vectors? So a scalar is a quantity which is defined by magnitude only. So for example, if I say 15 kilograms of mangoes, so this information is complete. So specifically, you don't need any sense of direction regarding this information because this information is complete in itself. So if I come to some physical quantities, for example, length. So if I tell you that an object has a length 5 meters, this information is also complete and you don't need any additional information, especially direction. Do you want to know something about direction? Like 5 meters. So I mean that this quantity is scalar, mean it is completely described by its magnitude. For example, time. If I say 60 seconds, which is equal to 1 minute, of course, it is also a scalar quantity because it is completely described by its magnitude 60 and of course the unit second, and it's complete. You don't need any additional information, especially direction. Like if I tell you 60 seconds, it's enough, right? Now let's see the definition of vector. Vector is a quantity which needs a magnitude and and direction. And what is a vector quantity? For example, force. So if I say I am applying a force of 2 Newton eastward. So basically, I am giving you two pieces of information. First is magnitude, that how much amount of force am I applying, which is 2 Newton. And I am giving you an additional information that in which direction I am applying this force. So force is a vector quantity because whenever you want to give me the information about force, you should give me the information of direction, in which direction you are applying the force. And of course, I also need the magnitude. Similarly, we have many physical quantities which are vector. One is velocity. So velocity is basically speed, which we commonly use in our daily life. That what is the speed? For example, I give you some information that I am heading towards west with a speed of 60 kilometers per hour, and I am heading towards west, I mean in the west direction. So this is velocity because I am giving you my speed. This, so speed is scalar quantity. So it means if I tell you, oh, I am speeding at 60 kilometers per hour, so it is speed. But if I say I am heading towards west at a speed of 60 kilometers per hour, now I am telling you the velocity. So in physics, velocity is a vector quantity, and it is actually a combination of speed plus direction. So whatever direction you can give, it depends on the situation. So I hope you understand what is vector and what is a scalar. Now do let's solve this question, which says that represent a force of 80 Newton acting towards north of east. So I have a map here, because whenever you want to represent a vector, you know a vector has a direction. And to show the direction, we should have a frame of reference. And then, of course, I can show the direction. For example, north of east, it means between north and east. But first, I should have a frame of reference, because in that I will define what is north, what is east, and then I can represent the vector accordingly. So first I need to establish a frame of reference. So I draw this line and then I draw another line here. Okay. So I can just move it here. It's up to you. And then I need to define what are the directions according to this map. So I will say that this is north, this is east, west, and south. Now next we need to define the vector. So we are given this magnitude. So this magnitude will become the length of the line, because we define a vector with an arrow. This arrow gives the direction of the vector quantity, and length of this line gives the magnitude of the vector. So it means I have to draw a line somewhere here, because the direction is north of east. So I can just draw any line in between these two directions, north and east. Now how will I represent 80 Newton in terms of length? For that I need to establish a scale. For example, because I will represent the length of the line, of course this is length, and I need to transform this 80 Newton into the length. So if I have the scale here, so I will just adjust it like that. So here, so I can represent it anywhere there, or maybe I can put the 0 at the origin of these directions. So now I will just draw a line which is directed north of east, but I have to decide what should be the length of this line which I will draw, and that length should correspond to 80 Newton. So for that I need to make a scale. So I will choose a scale that here the units are centimeters. So my scale is showing centimeter scale here, my ruler. So I think it's convenient, it's 8 centimeters. So I can say that 1 centimeter length will represent no, not 1, 10 Newton force. So now it's easy, right? Every 1 centimeter length will represent 10 Newton force. So according to this scale, 80 Newton force will be equal to 8 centimeters in total. So now I know that how should I how long the line must be. So I start from 0 I am at 1 centimeter, so this length is showing 10 Newton force. Then I go another 1 centimeter, mean I am now at 2 centimeter. This is the force 20 Newton. So if I go all the way to 8, now this whole length is representing 80 Newton force. I don't need my scale, so I will just put it aside, and I need to draw an arrow which will give me the direction, and I already have the frame of reference north and east. It is in the middle of north and east, so a vector should look like that. And because the length is 8 centimeter, it is 80 Newton force. This is how we represent a vector. So I will just go to the conclusion. We studied about scalars and vectors. Some physical quantities are scalars, some are vectors. And now we have learned that how can we represent a vector quantity graphically.